Cool. Phil, for those of you who were in the last one, thanks for coming back. I guess you can stand another hour of my voice somehow, but, thanks. For those of you who haven't, if you got any questions throughout this thing, just shout them out, because some of the stuff might be building on what we were showing before. So, I guess, is anybody here? Were you not in the first one? Okay. Cool. We'll just do the shortened bio. This is me. This is my future fiance, getting married in June. Our dog. Been doing CAD for about 6 years. Professionally in SolidWorks for about 3. One was actually working at a sheet metal fabricator in Chicago. Before that, I was doing continuous improvement for RFID and automotive companies. So a little bit spread here and there. Joined Fisher back in 2015. I'm an application engineer right here in Grand Rapids, so just right by that weather ball. If you know the area, that's kind of where our office is. So, mostly doing demos and training. I love it too. It's a lot of fun. You guys make it easy though. So, and then a shout out for any Western Michigan fans. Go Broncos! So that's me. So let's get to the stuff you came here for. So we're going to be building on a little bit of what we saw before. We're going to jump into understanding your drawings and flat patterns. So we were building a lot of stuff before. Structure of this session is going to be a little bit different. Last time I was just talking for like 20 minutes straight and kind of boring you probably, and then jumping into the software. This time I'm going to be showing you something and then jumping in. So a little bit more back and forth so it's not as stagnant, hopefully. So we'll be taking a look at drawings, flat patterns. Again, I left it at state of sheet metal parts. State of sheet metal features, but more advanced features, so ones that we hadn't seen last session. And we're actually going to take a look at the costing tool and then the converting of sheet metal parts. So there's kind of a couple different methods in there we'll take a look at. And then we'll leave some time for questions at the end. So I'll probably have about 10 minutes or so for that if you have them, or you can just ask them throughout if you need to. Okay, drawings and flats though. So when we start talking about flats, flat patterns, I'm hoping at this point that all of you know that flat patterns are technically an editable feature. So you can go in there, start changing things around. There's a lot of different options you can actually start going in there to mess around with. And then once we start kind of playing in here, I'm going to start looking at the sheet metal drawings, how you can directly import them in there, reorient your flats, get your cutlass properties. So I'll kind of re-show what cutlass properties are for the few people who wouldn't make it to the first one. And then we'll take a look at bend tables. These are going to be different bend tables than kind of the ones for bend allowances, and then kind of how you can directly export to DXF. So let's get into the software. Again, remind me if I'm talking too fast. It just kind of happens when we're in these things. So, okay. So editing that sheet metal flat pattern. So if I flatten this thing out, I kind of got my whole bounding box, all this other stuff going on. But there is, if we kind of look at this little down arrow thing here, there's stuff kind of collapsed underneath your flat pattern. And if you go even further, there's all this other stuff, and basically all this is all those bends that are included to create that flat. So it's kind of the reverse of all the stuff that you're doing up here. But if we right click on this flat pattern, go to edit that feature, first thing it's showing you is your fixed face. And then we got this option for merge faces. So what this is referring to is if you've got maybe, I don't know, if you want to show your bend lines as actual lines themselves, that's kind of where the tangent edges hit and it starts actually unbending. So if I toggle this off and hit my check mark and we take a look at our flat pattern, you can start to see all those things that are included on that line. And then you're still going to have your bend line in the center of it, so it's all still there. That's just kind of one of those options if you need to use it. So if we go back in there though and edit this thing, simplify bends, this is for if you've got like kind of complexer curves, it'll end up kind of simplifying them to smooth it out. It's going to be more linear instead of curves. It's just one of those options for you to include. And then show slit. So this is if you've got your corner treatments and it's kind of too tight. It's actually going to pop open some of the material on the corner, so it would just be like a tiny little slit there. That's just one of those options to also turn on. And then if you keep going down here, this thing for corner treatment. So normally in my part, I've got these auto reliefs going on, and it's going to show them. It only shows them when you have that corner treatment option turned off. So if I go and actually back in here and turn this thing on, we look at those corners again. It's just kind of basically in a tear mode instead of an actual corner treatment itself. So, but yeah, just a couple things in there. You can change your grain direction. If you want to specify that, you just select an edge, click OK, check mark, and it kind of specifies that. So while we're still inside the software though, if you want to just quickly directly export your DXF, I mean, this is just another option for all those other people out there. If I right click on this thing, I can go down, and yours might be hidden or somewhere else, but maybe you have to hit this down arrow. It should say export to DXF DWG somewhere on your list though. When you click that, it's going to say where do you want to save this thing, and then it's actually going to open up a new feature manager tree over here for you to start specifying things. So for this, I'm going to toggle on my sheet metal, and then I'm also going to be able to choose the certain aspects of my model I want to actually include. You can have hidden lines, bend lines, so we can toggle these on. The nice thing about it is when I hit this check mark, it's not just going to shoot something off. It's going to give me a preview of what this DXF is going to look like beforehand, which is going to allow me to edit it. So if I want certain edges, maybe I've got some of these lines on here. If I want to remove some of them, I can box over it and just delete them. So if there's other holes in here, again, you can just delete certain things. And then whenever you get it to whatever you want it to actually look like, you can just go ahead and click save, and it'll save something off. So that's another option if you want to go about it that method, or actually have it in your drawings instead. So, but when we start talking about this flat pattern, or this flat actually going over to your drawing. So right now, if we look at this configuration tree, there's only one item on it, right? There's no drop down arrow, nothing. But as soon as I go and say make a drawing from part, we'll just go ahead and open one up. For this, we'll choose CNC. And then if I go ahead and actually toggle back to my part over here, there's some new stuff included. So it's going to have that derived flat pattern listed underneath there now. So you can start going in there and taking a look at that and manipulating that instead. And this is one of the things that often people will end up doing, which kind of will kind of mess things up. So immediately as soon as I come into here, I'm going to have this option for my flat pattern. What I know in support a lot of people see is maybe you want to then take a look at your part. So you just right click on it here, say open part, and then they'll start actually just going back in here and unflattening it. So as soon as you do that though, the problem is you're technically still under that flat derived. So you just changed it to a form part. So if I go back here, now it's just showing me what that form piece is. So this is just one of those things to be aware of. It happens to a lot of people. So just be cautious kind of when you're in there, not to mess that one up. If you want to do it, you bring that back to flat. Just be sure to toggle this thing back on and then take a look at it. It's easy enough. So we've got this flat pattern though. I don't know if people have certain ways that they like to orient their part. I don't, that's not really anything that I know about. But there are ways that you can reorient it. So you can obviously change it over here on this left side. You can just start typing in certain things, and it's going to update. You can also use your little rotate model thing, and it's going to update that as well. It's all the same. Another thing to note is if you've got all these bend notes and you don't want them, if you click on one, you do Control A, you can select them all at once, and then there's an option to hide it. That's one way you can do it. Let's say you actually want to get these things back though, now that they're all gone. If I just go ahead over onto this left window and click this bend notes off, back on again, they'll come back. Or you can also right click on this thing, go to properties, and then you're going to have an option down here to display sheet metal bend notes. This is basically the same exact toggle as over here. It's just another way to get to it.
Showing starts and ends of radius or bend lines on your flat pattern.
Sorry, what's that?
Them bend lines, is that start and end of radius? There's two lines there.
It's sorry. That's
you're showing
that's
the bend line in the middle.
yeah. So that's from when I added the other things before, but that's to the bend line in the middle there. So a little confusing now because we changed it. So
if you delete those off, those selection boxes won't get that done.
if I delete them, it doesn't really let you. None of the selected entities can be deleted. So since it's like one of those toggles over here, I guess it's just kind of one of those things. So again, you can change all this stuff. You want to right click, change some of that, the text, etc., etc. Okay, but so we were talking about the cut properties before, that whole big list of things. So people who weren't in here before, when you kind of look in this cut list, you got your sheets. So if you got multiple pieces of sheet metal, you go to properties, you're going to have all this information about your part, right? Bounding box, cutting lines, etc. Inside of this actual drawing, a lot of times you might want that information, right? So if I go ahead and right click on any flat pattern inside of here, you can go down to annotations, and there's going to be an option down here for cut list properties. And when you click that, it's going to bring all of that information into a text box that's then editable. So if you don't want half of this stuff in here, you can just start deleting it then, or changing kind of whatever it is. So it's just another way to get all that info in there quick for that special notes. Another thing, if you want to actually start changing, so on the slides we were showing you can change colors and whatnot. If you, in your template, want to have certain bends be certain colors, if we go down to the document properties, go to sheet metal, you can then start changing the color for your bend lines for the up direction, down direction. Kind of a lot of different options in here for you to kind of change around. Another thing to note is, again, if I right click, go to properties, we can actually show that display bounding box. So if you want to have that showing, that's just another way to toggle it on.
And the colors, if you change them on there, will they change in your DXF as well, or is that totally different?
I think you'd have to set it to a certain layer first, because then when we were saving as DXF, there was like a layer property thing that popped up, but I personally haven't tried it, so
You've been limited in what?
what's that?
You've been limited drawing a layer stuff.
Yeah, so yep, that'd be something might have to test out a little bit. Okay, so drawings though. So let's see. I skipped one thing in there. So the next version of bend tables, it's not actually referring to your bend allowance at all. This instead is referring to a quick list of all the various bends that are inside of your flat pattern. You can start kind of obviously changing a lot of this customization that you normally have. If I bring it over here, it kind of shows me this entire list of things, and I can start moving these things around as needed, as in any other drawing kind of section. You can also add different columns in there. There's certain ones that will pop up specifically for this. If I can get it, there we go. So if you want to show, because right now it's showing you that angle, if you want to show the complementary angle or something as well, you can add another column specifically for that. But it's just kind of a nice clean way to have all of those bends placed and shown instead of having all those numbers all over the place. Nice thing about it too is maybe if you want to start rearranging these things, it can live update. So if I kind of click over something and start moving it, it's going to start altering all those numbers, whatever they are. It'll start to change it. So hopefully you can kind of see it. Yeah. So if you look at that one in the middle, it's kind of changing as I'm moving this thing around. So, okay. Alrighty. So I might actually just kind of cover over a couple of these real quick, just so I don't have to keep jumping in and out of PowerPoint. Gussets. So 2014, these were actually introduced. 2015, it actually gave you what you probably wanted, which allowed you to see the gusset profile on your flats, along with the gusset center and flat. A couple different ways to see it. Along with this, we're going to start covering lofted bends. So we're talking about the base flange before. That's one way to start a sheet metal part. This is going to be your second way that we're going to start talking about. Nice thing about it is they changed the way the bent ones work, where you actually have some options to control it with kind of these 4 different selections in the bottom with chord tolerance, number of bends, segment length, segment angle. There's a quick little description on what each and all of these do. We can actually see what they do and test them out. Another cool thing, at least I really like it. In 2015, they allowed you to start doing it to not parallel planes. So if you look at this one over here, this one's kind of off on an angle. It all still works. You used to have both of those things lined up perfectly parallel, otherwise it wouldn't work. Also, another thing to note is there's a bunch of already preset lofted bends in your design library. So sometimes you might not have to build your own. You can just drag and drop them if you want to. It's just an option that's out there for you to know about. And then I guess we'll just keep going. So slip flanges. This is going to be that third option that we were talking about for that base sheet metal part. 2014 gave you the option to have more of this cylindrical conical body. So instead of getting this not accurate at all, just square flat, you're getting this option to have that full unrolled kind of thing about it. And this is kind of that standard swept flange for you. And then we'll show you kind of what some cuts in swept flanges will look like. I think this is new in 2016, where it actually shows it. In 2015, it used to just, I think, go away, if I'm not mistaken. So we'll actually go ahead and jump in there, though, because I just kind of talked about a lot of things there. So alrighty. Okay. So first of all, gussets. Where are they at? How do you use them? Up on this top tab here, right in the middle, sheet metal gussets. What you're doing is checking 2 perpendicular faces. Kind of go into one another, and it's automatically selecting certain edges for you. You can change these if you want. Right now, this offset point's on this one down here. You can also change offsets, 6 inches, and then there's this whole crazy bunch of different options for dimensioning. I think this is something for you to play around with. I don't know if it's kind of worth my time telling you exactly how all these things affect everything, because we can check out a lot of other cool things. This is showing it, though, that you can change it for configurations right there. And then if we go down here, there's even more stuff with indent width, indent thickness, and a lot of this other fun stuff. So I'm just going to leave it at this. If we go ahead and click OK, we're going to get that gusset. Around to the back side, you'll see it's kind of got that open face on the back. And then let's go ahead and actually go to our flat pattern. And right now it's not showing. So this is going to be something that's controlled by either inside here, you can override your document properties, or you can set them if you've got your certain specific ones you want to change. It's just under the document properties, sheet metal, and then there's going to be the option for show sheet metal gusset profile when flattened, and then show sheet metal gusset centers when flattened. So if we toggle those on, we can start to get what that outline looks like. So pretty cool little enhancement there from 2015. Okay, where was that? Lofted bend. So we've got some parts here. Open this up. So first version we'll talk about is bent ones. So there's kind of 2 different methods you can go with. It's either bent or formed. So that's kind of adding in those actual bends or actually rolling it more so. It's kind of those two differences between those two. If I go ahead and select this, so I guess first thing to note is when you're building this, you gotta have two profiles. And then when you're selecting these things, be sure to select them in similar locations where they would most likely come together. So if I selected it over here and over here, and it's mostly like that's kind of going to make things difficult. You're going to get a weird part that's not actually doable. So if I select the circle here, I'm kind of in a similar location where I'd see it come across, it's going to then be able to actually identify what that's going to look like. So this is in this first version of bent. There's also another thing of formed. And then we can start going down in here into these chord tolerances, number of bends. One pretty cool thing to note is you can actually change each corner individually if you wanted to. So if you click these little pink baubles, it's default going to be stuck on the default options. So whatever is determined over here on the left, that's what this is. You can change them individually though to segment angles, segment length, all those other options over there on the left hand side. So
Is this where them internal bends are all twice as big as the two external bends on each corner?
say that again?
The bends aren't all equal. The first and last bend on each corner is half of all the ones in between.
For these two?
Yeah, take a look at them.
I don't believe so.
The middle ones will be twice as big.
Don't know if you'll get that on these ones.
At the surface of each one.
So if we go ahead and flatten it. You're talking about in flat or in the form state? No, I guess it really isn't going to matter.
You could draw the flat pattern and read the angle.
So that one's 35.73. That one's a little bit shorter at 36. So is that what you're referring to?
The arcs are the same, but the angles are different.
So I mean that's kind of where all those various different options we were looking at can come into play, right? Because on this one, all those angles are the same. That's what we were setting.
The guy making it out in the shop, if he's making that on hand rake, he'd like to make them all the bends pretty equal.
Okay. So that might be where you just kind of play around with which one of these selections you're using. I mean, I'll be honest, I'm not going to know every single answer to all these questions because I'm not doing this every day. You guys are. So I'm going to know the software a little bit better, or I like to think so. Some people have been using it for a long time, but yeah. So if somebody knows, I'm not too sure. Maybe check back with me after, and I'll.
Well, I
Yeah.
know a way of getting them equal, but it's a little bit of work.
Okay.
In this case, the two outer bends are starting right on where the start of the radius of that quarter circle. You have to come in a half of the normal angle between the big bends. You have to start at half off, and then it works. Is that so I was showing him a minute ago?
Okay. Yeah, on the sheet of paper.
No.
Gotcha.
If you bring it in a drawing in the flat, though, it would give you the angles.
Yeah, it'll give you the angles. Yep. Because that's what we were setting for these ones, right? I mean, if we had it set to segment length, it'd be different, right? But
Well, I'm making big, heavy sheet metal parts. I'm making them a press brake.
mm-hmm.
And what the guy does is to get the radius started, he sets it and runs a small part. And he sets the die and he runs about 4 parts through before he finally gets the circle to come out right.
Okay.
So he has to have all bends equal.
Okay.
Because he can't do that.
Gotcha. So that might be this chord tolerance one. I'll play around with it after and then get you something because I guess I just want to keep moving here with kind of all the rest of the stuff we got going on here. Okay. Oopsies. Forgot to show something else. All right. kind of if we keep going down this list of options, though, we've got this choice for refer to endpoint. And with it toggled on, it's going to kind of make this corner as sharp as it possibly can. If we have it toggled off, it's going to instead round this thing out so it's not kind of doing that cracking or impacting the part. And then we can jump out of there. So, but that's that bent version of it. If we open up another part here for this formed, do another one. And something like this, if we go to form, right now it's just got, it doesn't really have any of those bend lines in there, it's just got the one. If we go ahead and click this OK, it's not really showing things as much, but there's another way around this, and that's if you actually segment some of the lines up top. So basically the same thing, but if we look at this top circle, it's kind of got these lines broken down into it, so it can go to different segments. So when I go to this lofted bend, actually choose it, we can start to see instead some of those form lines, and it gives you that bend line control for those formed ones instead. So if we toggle this up to something like 8, and then actually flatten it out, it's kind of got those 8 different formed sections. And again, this is just another one of those things that you can control. So a little more options in there. So okay. Right, SWUG flanges. Okay. So we were talking about that first one of conical SWUG flanges. Obviously, when we're talking about these things, first thing to note about a lot of these swept things, or even you saw in the lofted one, is you need to have a gap. Hopefully, it's one of those things that's kind of known, but if not, that's kind of how it works. You need to have some sort of gap so that the sheet metal can actually be made somehow. So if we go to SWUG flange, choosing my profile, and then I'm choosing my sketch. And then when we start getting into here, there's a lot of different options. I think I've got an example for this flattened along path, what that's actually going to do for you. And then we've got this one for cylindrical conical bodies. So when you toggle this on, though, so it needs some sort of reference on what you're actually trying to determine that conical edge from. So we go down here and choose this bottom edge. It's kind of my starting point of where plan flatten can become or start from. So I do my check mark, go to my flatten. Yeah, somehow reorient this thing. Okay. So I've got that actual accurate version of what that part would more so look like. If we actually went back and changed the SWUG flange just to a regular one, obviously when we go into it, it's just going to be that flat. It's not very accurate. It's not how we get the part. It's not how we cut it. So quick one on that. And then actually getting into regular swept flanges. So kind of showed you one version. Again, you're always going to need a profile and a path. So on this one, I've got my profile and then my path again. And then this one is actually where we're going to show, because right now if I just went ahead and clicked the check mark and went to this flat, we're going to get this thing. Maybe you want it actually to be a little bit different looking when you cut it, to kind of save some steps possibly. So we go to edit feature, go to flatten along path. Just go ahead and click check mark. Material and size is not important. If we go to this flatten, it's instead kind of whatever that path I had set, it's flattening it along that instead of flattening it out to an actual form spot. So maybe that would take away the fact of having that bend. You can just cut it like this and go. So a couple options in there, working around with that stuff. Okay. Next thing we got was the cut and sweep. So depending on how you want your actual cut to look like, you can unfold this thing, take the cut out, refold it. For this, we'll actually start looking at just doing an extruded cut straight from the center here. Then again, I can just do a through all, and we're going to get into normal cut and what this optimized geometry thing is going to do probably in about 10 minutes or so. Because that's one important thing that can affect the output of what this actual cut looks like. If I go to this thing, right now it's looking cylindrical, right? But if I actually go to the flat pattern, we're getting more of that oval shape. So that's one of those things where you get to decide what your shape actually needs to look like when it's in that formed state. Okay. We'll just. All right, we'll just leave it in this little way. Next thing is forming tools. Is anybody actually using these a lot? Forming tools? No? All right, maybe we'll leave this for the end if we want to jump back into it, if we got time. Next thing I want to show you, though, is other ways to add bends. So far, we've mostly just been going straight from edge flanges, jumping off to things. There's two other methods that we can use to add it to actual sheet metal parts. First one's going to be sketch bends. Second one's going to be jogs. So get back to the part. I'm just going to close a couple of these out real quick. Do it same. Okay. So we've got something like this. Maybe I want to actually start adding some bends to it. This is where the jog can come into play. Actually, I'm going to add the sketch first. So for this thing, when you're using jogs, you can have lines go all the way to the edge of the material, or you can just have them kind of shorten sides. It works kind of how ribs work if you've used those. You don't have to have actually things go all the way to the edges for it to actually understand what you're looking for it to do, because how are you going to have kind of a corner bend in the middle there. So if I go to jog, it's asking me for, okay, what's your fixed face? Select it, and then it's going to take whatever that point is, and you're going to get a lot of that same choices for like we had in edge flanges of where you actually want that bend to occur at. You're going to have those same options down here below and for jog position, and you're also going to have that jog angle. One key thing to note is if you've already got like the entire length of your part set, maybe you started on that piece that was already exactly however long you wanted it. You can actually toggle on or off this fixed projected length, and what that's going to do is if I start making this jog bigger, it's going to start affecting that overall length of the part. So you can start changing it depending on how you want it. And again, if you've got this in a multi-body environment, you can start using some up to vertex, up to surfaces, some of these other tools inside there for you. Another cool thing to note, though, is you don't have to be using straight lines for this. If I have something crooked off like this maybe, for whatever reason, and I want to use a jog, it's going to work all the same way. It's just going to angle it off instead. Again, works out pretty nicely. You can kind of change that direction of whatever bend direction you actually want that thing to go off in. So we can go ahead and click that OK. When we take a look at that flat pattern, it's actually going to have kind of that jagged offset. That would be how that part would actually lie. So pretty cool right there. So maybe instead of having a jog on this first one, though, I actually want this thing to instead be a sketched bend. So it's going to work very similar to how we had that jog, except for sketch bends are just going to be one instead of that jog being kind of that first bend and then evening off. So we go in here, again, select that sketch. It's asking me for a fixed face once more, and it's just going to add it straight in there. So it's kind of just how do I want to create my parts. So this is just another method. If you just want to make that plate first and then add the bends in later, it might be easier depending on kind of how you actually do things. Just two additional options that get in there. So, but let's actually start talking about normal cuts and kind of how those are affected. So, I was looking online for a lot of different information on what that optimized geometry thing actually does. They honestly don't have a lot of information on what it's clearly doing in the background, other than saying that it's smoothing out surfaces and creating a more realistic cut. That doesn't really tell me a whole lot of things. I was searching all over a bunch of different forums and knowledge bases, and it's just not too much. But there's this one example of what it looks like in 2016 versus 2017 with the optimized geometry toggle turned on. It just, instead of having, I think this was from a slot, instead of having it look something like this, it ended up creating that full smooth feature. So it's just inside that cut extrude feature right under your normal cut. It's going to say optimized geometry. So if we actually get in here though and start using this thing to see kind of what the implications of using normal cut versus not using normal cut is going to look like. So okay. So if I've got these two things, and maybe I want to cut them through all of my material. Maybe there's going to be a bolt or something going through here, and maybe this is just, I don't know, a slot that you want to create. If I go into that extruded cut, go ahead and select that sketch. For this, I'm just going to do through all. So first I'm going to show what it's going to look like without the normal cut applied. I'm sure you can all imagine what it's going to look like, but just to see it. So when we get this thing and we actually turn it into a flat pattern, we start looking at kind of how those lines lay out. It kind of creates all that extra flattening there. So it's kind of just cutting straight through your material. It's not exactly normal to that surface. So when we're talking about normal cuts, it's literally going to do your cut normal to the surface. So we'll turn that thing on. We're not going to turn on optimized geometry yet because I want you to see what it looks like just with it once. But if we turn on that normal cut, instead of having that kind of slanted cut through it, wherever that circle face lies on that edge of the piece, it's going to cut it normal to that surface. So perpendicular wherever it is, it's going to cut it. So when I get my flatten, I'm not going to have that double line showing it all. It's just going to be straight through. Okay, so again, just want to show one more thing on that. And I found this kind of curious. I still have yet to figure out why it did what it did, but you'll see in about a second.
You get that double cut out of there, you have to have.
What's that?
Pick a different, you have to pick something else, right?
To get the double cut out.
Pick that cut, you pick it, if you just do it normally, you'll get that little, on the angled cut, you'll get that little bump or whatever it is.
Yep.
How do you get to that?
So that's turning on this normal cut option.
Oh, okay.
So it's just so instead of just cutting straight through your material, it's looking at the material, understanding it's sheet metal, and applying that cut normal to the face instead.
Which face is it normal to, the inside or the outside?
That is a very good question.
I think it does the opening big enough for that cylinder to go that shape to pass through. I believe it goes both sides.
Okay.
You cut that to look straight at the end.
Are you okay? I see what you're saying.
Yeah.
So a shape that matches that would be.
That normal cut's been solid works for a while.
It has.
What hasn't been is they're taking the little bumps out
Taking the little bumps out.
that you were talking about.
Oh, you're talking about the.
That's in 217 or 216 or something.
So you're talking about when you optimize geometry.
Normal cut.
Yep.
Normal cut, so you can slide it. You take a round circle. I got a sample of it done here
Mm-hmm.
on a dump trailer.
Okay.
Where
It's on his PowerPoint slide, you're saying, the little one that was on your PowerPoint?
I'm not found. Yeah, you're talking about this one with these bumps here.
yeah.
Yeah. So that's that optimized geometry.
Yeah. You can take them out now.
Yeah, but
But it worked.
there's certain times that
It
you.
worked.
Yep.
I had done it out in the shop. The old way was close enough.
Yeah, okay. There are certain times, though, you're not going to want to use this optimized geometry, and this is going to be one of them, because I tried looking. I don't really understand why it's trying to do this, but this is just one thing to be aware of, that this can happen. I took that slot and it just expanded all the way over to, this
Normal cut's been in
this
there
flat
for like
edge. So
6 or 7 years, isn't it?
yep. So all they added in the only thing that was added in the only thing that's added in 2017 is this optimized geometry toggle, and all they're saying it is smoothing things out. So I think I'm not sure if you can see it. So let me see if I can add something real quick, because you can see it when you actually cut a circle on the edge of something like this on what it's doing. Like it's basically just trying to smooth things out to a more normalized geometry, I guess. So let me see if I can add something. Ah, crap. So if I just added a cut to this, I don't know why I do this, but it's an option. So if I cut, do a, oh man, let's do it through all. So, okay, one second. Turn off that optimized geometry. We look at this little corner, and maybe it's not going to work the way I was showing it before, but if we turn that thing back on, okay, so I don't know why. I was doing an example before earlier where basically these little segments weren't in there. When you have optimized geometry turned on, it basically added them in there, so it's just trying to smooth things out a little bit more. So maybe it's going to depend on the size of certain cuts, kind of where it's coming from, but that optimized geometry is just there to kind of smooth things out a little bit more. So there are certain times that you might not want to use them. I was looking online, and it's just a couple different things that might kind of mess it up. Obviously, we were showing it earlier where you're actually cutting at that angle and you want it to have that. You don't want to use the normal cut there. And then there's another thing up here where they're cutting it through here, and with the normal cut turned on, actually just removed all this geometry. So there's certain times where things just aren't really going to work exactly how you want it to. So just something to be aware of as you're working with that normal cut. Cool. So next thing though is going to be the costing tool. So if you've got professional and premium, you've got access to the costing tool. I will say that it's meant to be more of an accurate, or a just quick and fast costing tool. I think they're saying it's like 95% accurate, so you're gonna have some leeway. It's kind of one of those things, if you need to get a quote out just quickly, shoot it off. This is going to be the way to do it, because it takes some refining in the background to set up your templates and all of your processes and material thickness and all this other stuff that it's using in the background to actually how you're using it at your company. So there are standard templates though available for you, and it allows you to kind of define various operation costs for like laser, plasma, water jet cutters, and it's actually going to track your setup and a lot of this other stuff as well as it goes. So nice thing about it is all those templates can be modified. So if I jump back in here, go to costing. So maybe you've got a part that looks something like this. You're going to find your costing tool under the evaluate tab. Just going over to costing. And then it's basically just going to be a new little tab over here on the command manager. So this is used for sheet metal parts and machine parts, and those two only. So if you're looking to use it, that's just kind of what's there. When we're talking about that template editor, you can go into it pretty easily. It's just launch template editor, and then you can start playing around with all this stuff. So if you've got a certain list of materials you want to utilize, then you can start getting into all this fun stuff of costs and thicknesses and things that are basically updated every month, I think is when it was for us. So these things get updated all the time. So this is kind of one of those things where somebody would probably have to be updating this, or we'll get into it down here. There's an option to basically override whatever that default cost option is and set your own. So as those updates come through, you just kind of type it in there. We were talking about, again, all of these different operations that can be done, cutting, bending. If you have got various library features, it is only, I think it's under this one. So it's only the cost per millimeter. So I don't think you can do it by time. So I know that was something that people were asking about a lot. I haven't found a way to get it to calculate cost of dollar by time. So, but it's set by kind of whatever the thickness of material is and whatever your cutting method is. It's got all this stuff in there. There's also things that you can set up for rules. So if a circle's a certain diameter up to a certain threshold, use this type of tool or this type of cutting method, and then as soon as it passes that, you can say, hey, use this tool instead. So you can start setting up all these rules in the background and start having this thing drive it, and all other information. So if I go ahead and lock this thing, though, what I'm doing is basically setting a base cost, and then as soon as you run your costing, apparently it already ran for me, you're going to get this whole thing over here for setup times, cut paths, kind of how much all these things cost and associated information. And that's not going to click up there. So if I start to actually change this thing, maybe I want to use a different material or something. I don't know. You can start to see kind of what these changes that you make and how they're affecting your cost. And why this might be important is once you're done, you can then export off a report and actually get a fully, let me open it up real quick. Okay, so the report is going to look like this. So it's going to say, hey, here's all this stuff, here's the various cut paths, what's associated with all of this stuff, and kind of the various cost choices you had. So what your baseline settings are and what some other settings are. Okay, getting close on time here, so we'll jump back over. So converting models to sheet metal. This happens fairly often. There's two main methods to actually do this, and each one is kind of set for certain reasons. The first one is going to be the insert bends method. So this is going to be for imported sheet metal parts. So if somebody sends something over from, I don't know, Inventor or something, this will be how you do that. It also can be used very easily with shelled SolidWorks parts. And then there's a second way, which is going to be converting using the sheet metal feature. So that's going to be used for kind of your standard full-bodied parts that aren't going to be kind of shelled yet. So, oh man, I jumped over too quick. So, we'll just look at it here. Screw it. Insert bends, though. Way this thing is working is you're basically taking this shelled part or this imported part and you're actually ripping those edges open, and then you're going in and adding bends individually to the places that you want them to be. Cool thing about this is you can also use it for these conical parts. So if this thing comes in and it's just a piece that can't really be unfolded, you can go ahead and do that. Likewise with this convert to sheet metal, one thing to note is if you're trying to get your CSWP sheet metal thing, this is going to be one of those things on there. It's going to use a multitude of commands in the background. So what it's basically doing is taking this sheet metal part and then it's shelling it, kind of ripping whatever edges you have and adding bends kind of all in one step. So if this thing ever fails, you can always just try and do these things one at a time, start shelling it and then going at it. But that kind of brings you back to this insert bends method, which it isn't really all too helpful. So if we jump over here though, let's see, we're going to just open an IGES that somebody sent maybe. Import diagnostics, maybe we got some edge going on. Let's go ahead and try and heal it. Cool. And then pass on feature recognition. So under this sheet metal, over here on this far right, we're going to have this rip command. And what you're doing here is basically whatever these hard corners are that you want to get rid of, you're just kind of selecting them. So we've also got these little arrows going on. So what this is doing is showing the threshold of where your actual sheet metal faces are, and it's going to get rid of all the material on the back side of it. So I mean, it's kind of giving me this information here kind of on where it's going to go. So for the thickness though, I'll just leave it at 0.01 inch for the sake of it, and then click OK. And then it's actually going to take that cutout so we can kind of see this open space here. All right, hold on, let me turn this off. I was making that blue box, so make these hard edges. So you can see, like I was talking about, took that backside information out. So this might take some more time on more complex parts. Obviously this one is very, very simple. But then at this point, all you're basically doing is then selecting those edges that would be, actually, sorry, first part you're selecting the face, and then it's kind of going to where it's going to go to. So it's looking at this face, seeing all the connected edges to it. When I hit this check, saying, hey, auto relief cuts were made, bends were applied. Again, it's being based off of this sheet metal information, so if you want to change it, you can right click, add feature, start changing a lot of this stuff. And then we've got our flat. So again, that's kind of a very basic example of how that thing works, but kind of whatever you move it to, it's going to be a lot of the similar same things. So if you want to actually convert from a full part, sometimes it's easier to make sheet metal parts actually, for whatever reason, you can just make them as a solid and then convert them over. Sometimes it's just the mechanics of maybe how your brain works and how you're building models. It might just be something you want to do instead. So let's say we've got this piece, and I want to take this thing and actually turn it to a sheet metal part. So I can go to this convert to sheet metal, and again, you can start utilizing gauge tables if you want to. So if you toggle this thing on, start selecting something, it makes it really easy to actually start going from there. So first box though, what's my fixed face? I'm just going to make this top face be it. I'm going to move this thing up to a smaller thickness. And then again, we've got our same things here. So you can reverse the thickness, so that's kind of that inside-outside. This keep body is going to be, do you want to keep that original body of this part? I don't really know why you want to keep it. It's just, it's there. I guess if you add the material to the outside, maybe it'd be, I don't know. But then down here in this box, this is where it actually starts to start working for you. So it's asking me, okay, where do you want to start applying bends to? And the really cool thing about this is as you start selecting these bend edges, it's going to start adding auto rips for you, so you don't have to do them yourself. You can, but it's got it set up in there where you don't have to. So anytime you got these pink line or purple lines, sorry, it's adding those rips in there for you. So if you can kind of follow what we got, this one bend coming down here. Maybe we want this triangle piece attached to it. So if again I select this edge here, it's going to rip that connection. It's going to build it off over there. Maybe I want this front face to be bending down to this one. Again, we can start to see that full rip being put into place. And when we look at this preview, we've got this full thickness going on there. So I'm just going to go ahead and add a couple more on there, so we can get this full part. Again, we got all these crazy little things listed up here. So obviously you can kind of edit those one by one instead of having them, oh no, be default. Okay. That's a good thing to actually note in there. So I click back in there and it actually loads for me quicker. You got your different kind of options for kind of how those gaps come together. So you got your gap thickness, overlap ratio, and then kind of if you want to have certain things specifically set for certain areas on your part, each of these are editable one by one. So but in here we've got all those auto rips shown over here. You're going to notice this rip sketches option available, so if you actually wanted to make like a 3D sketch or something to add rips in there yourself, it's an option. But if I go ahead, got all those edges selected, everything's kind of to the point I want it to be. If I hit my check mark, I've got my sheet metal part. So this is another way around that. If I flatten it, we got our full flat, full to the point where we kind of got it. So, but yeah, so again, you can go into unfold, fold, add cuts, change things from there, and kind of make it your process. So that's kind of what I had for you guys, though. So if you got any questions, if not, that does it for me.
How do you get that last part in the press brake?
I get the last part in the press bake. That's a good one. They don't pay me to answer those questions. I'm just kidding. No. Okay.
Get these complex stuff. No way. That's what you're looking at.